Hello everyone. Now that you have studied work done in an isothermal process, it's time to study work done in an adiabatic process. So we have already studied what is an adiabatic process. So adiabatic process is the process in which the heat is constant. Moreover, it is a fast process. So we know that here heat is constant and it is a fast process. And here Poisson's law is followed. Right? So we have to calculate the work done. What is the basic formula for work done? This is dW, this is PdV, and if we are expanding the gas, then for the expansion, V1 is the initial value of the volume and the final volume is V2, and this will be integrated for getting the total work done. So this will give us the total work done. The detailed steps we have already done in the isothermal process. Now from here we know that here Poisson's law is followed. So what is Poisson's law? This is PV to the power gamma is equal to constant. This constant, let's mark it by K. What is gamma over here? Gamma is the ratio of the specific heats at constant pressure and constant specific heat at constant volume. So this can be written as, pressure can be written as constant upon V to the power gamma, and this can be written as K V to the power minus gamma. Remember the difference between V and gamma. Students are often confused in this. So this is K V to the power minus gamma. Let's mark this as equation 1 and this as equation 2. So from 2 in 1, we'll get W is equal to, for P we are putting K V to the power minus gamma dV integration V1 to V2, right? We can keep this constant outside the integral sign, and then this is V1, this is V2, this is V to the power minus gamma dV, right? So from here W will be K, and what will be the integration of V to the power minus gamma? If you remember the formula, that x to the power n integration is given by x to the power n plus 1 upon n plus 1. So this is what? This is the formula. Right? So from here, if we are taking V as x, V is equivalent to x, right? So what can we do? So this is V to the power minus gamma plus 1 upon minus gamma plus 1, because V is equivalent to x and n is equivalent to minus gamma. So that way if we are putting the value, this is x to the power n plus 1 upon n plus 1. So this is V to the power minus gamma plus 1 upon minus gamma plus 1. So this is the integration. Now we have to put the limits. We know that to put the limits, what do? We place the upper limit and then subtract it by placing the lower limit. So this will be W is equal to K. Let's take this part outside because this will be a constant, So this will be minus gamma plus 1 as it is, and inside the bracket this will be minus gamma plus 1. This seems to be simple now, right? So we just have to place the upper limit for v because we are integrating with respect to v. So w is equal to k upon minus gamma plus 1 as it is, and for v we are putting v2, that is upper limit. This is v2 to the power minus gamma plus 1 minus lower limit for v, that is v1 minus gamma plus 1. Now in the next step, we can multiply this k inside the bracket. We can take it inside the bracket. What will happen? 1 by minus gamma plus 1, and this k can be written with v2 to the power minus gamma plus 1 minus k here also. So this is k v1 minus gamma plus 1. Right? Now we have to put the value of k. How to put the value of k? We know that pv to the power gamma is constant. This is what? This is Poisson's law. That means if we place it for two different positions, so this one will be p1 v1 to the power gamma is equal to p2 v2 to the power gamma is equal to k. That means p1 v1 to the power gamma is also k and p2 v2 to the power gamma is also k. So both can be considered equal to k because this is Poisson's law, which is followed in the adiabatic process. Now from here we can put the value according to our convenience. So let's mark some equations. This is second equation. This is third equation, and let's mark this as fourth one, right? So from 4 in 3, right, I have to put the value of k. So for v2, whatever is convenient to us, that value of k we will put. We can put k is equal to p1 v1 to the power gamma or p2 v2 to the power gamma according to our convenience. Here we know that its multiple is v2. That means the suffix 2 quantity is to be taken here for k. So what will we write? W is equal to 1 by minus gamma plus 1, and here for k what we are writing? 2 suffix value. So 2 suffix value is for k is p2 v2 to the power gamma, and v2 I am placing as it is. This is minus gamma plus 1 minus as it is. Again for this k, what value of k will we put? This value. Why? Because here we have one suffix. So we will write p1 v1 to the power gamma into v1 to the power minus gamma plus 1 as it is. Now the equation will become very simple. Why? Because we know that if bases are same, then the exponents are added. So from here w is 1 by minus gamma plus 1, and here p2 as it is, right, and v2 to the power gamma minus gamma plus 1. These are added because the base is same. Now here p1 as it is, and next term has v1 same, so we can write down v1 to the power, the exponents will be added, that means gamma minus gamma plus 1, right? As simple as that. Now just check out, can it be simplified? Yes, it can be simplified. How? This gamma and this gamma will be cancelled. this gamma and this gamma will be cancelled. So what will remain? W is equal to 1 by minus gamma plus 1. Here P2 V2 minus P1 V1. Right? So this can also be written as, if I take minus common from here, this will be P1 V1 minus P2 V2, and if I take minus common from the denominator, it will be gamma minus 1. So this minus minus can be cancelled. So this can be written as finally W is equal to P1 V1 minus P2 V2 upon gamma minus 1. This is one form of the formula, and the other form can be written from equation of state. Let's mark this as equation 5, which is the work done in an adiabatic process. Right? The other form we can write by using equation of state. So this can be written as, therefore W can also be written as N, number of moles is same for the gas. So N R T1 for P1 V1 and N R T2 for P2 V2, and this is gamma minus 1. So this can be written as NR T1 minus T2 upon gamma minus 1. So this is the other form of the work done in an adiabatic process. Right? And here you can mention the reason, since P1 V1 is written as NR T1 and P2 V2 is written as NR T2. The reason we have mentioned here. This is why the form of the equation has changed. So this was all about the work done in an adiabatic process. Hope you understood it. That's all for now. Have a nice day.